scientists have used some of the same basic techniques for decades to unlock the mysteries of Earth. The minerals that make up rocks contain the history of our planet. By patiently deciphering this history, scientists gain insights into our past and our possible future. If we can learn to cope with the harsh conditions on other planets, these same techniques can also be used to understand those worlds. That's why NASA's Ames Research Center is developing Telepresence, a tool that will allow astronaut scientists to range widely and freely in their first explorations of the red planet.
Let me adjust my head. Okay, that's perfect right there.
Telepresence uses many of the same control techniques that are being developed for computer-based virtual reality simulations, video headsets, joysticks, and tactile feedback devices. Whereas virtual reality simulators allow a user to interact with a computer-generated environment, Telepresence allows the operator to interact with the real environment. A robot whose camera vision and manipulators are slaved to the operator makes it possible.
I think telepresence will increase the fidelity of the science by allowing us to get closer to that environment that we're trying to study. If we can't really touch the environment, if we can't immerse ourselves into the environment and actually become involved with it, I don't think we'll have a true understanding of what we're trying to study.
To learn about the strengths and weaknesses of this new technology for planetary exploration, Telepresence is being used to study one of the harshest and least well-explored parts of our own planet, Antarctica. Here, as in the ocean depths, scientists use robots that allow them to penetrate the extremes of this hostile environment. In the dry valleys, temperatures are similar to those on Mars, and there is almost no precipitation. The Antarctic desert is the Earth's closest match to Mars. In addition to its harsh environment, Mars is a challenge to explore because of its considerable size. It has the same surface area as Earth's continents. In 1996, a Russian rover similar to this prototype will be sent to Mars to carry out geological fieldwork within a limited area. When humans finally make the trip, they will probably be part of an international team that will use telepresence to control similar vehicles. Most likely, a round-trip human mission to Mars will include a stay of about 1 year on the planet's surface, with people working out of a human base that will be reoccupied for many years. To assure the astronauts' safety, remotely operated vehicles, or ROVs, could be sent to explore areas in advance of on-site study by individuals.
I think it's very likely that you will never send a person onto the surface of Mars into a place that you haven't already put a robot reconnaissance traverse into, so that you have the best briefed human crew you can possibly have to go do that traverse. They understand that terrain. They've been through it, telepresent. The fidelity of the experience is such that you feel like it's happening to you, rather than you're just watching it passively on a screen.
Using several ROVs in different areas of the planet, the team of scientists will be able to study a much larger portion of the terrain in a much safer manner than if they actually traveled there in person. Exploring the planet in a spacesuit with a lunar-type rover would limit coverage to about a 30-kilometer radius because of life support limitations. Global reach can be achieved by the astronauts from within the safety of their base through robots controlled in real time using telepresence. Such robotic fieldwork will be unconstrained by hazards and the limitations of practical life support systems. As will be necessary on Mars, in the remote settings of Antarctica, humans and machines must complement each other's strengths to achieve scientific success. Mars once may have had ice-covered lakes similar to the ones in Antarctica. Exploring them using telepresence, robots provide an opportunity to learn more about how life may have evolved on Mars. At the same time, it allows a new planetary exploration technology to be developed. A key research tool is a remotely controlled mini-submarine with a video camera that is lowered into a 4-meter deep hole cut into the ice. A diver accompanying the sub into the 0-degree water can stay submerged for only relatively brief periods. But working from a base on the surface, the time for exploration is greatly increased. Researchers use intuitive head motions to control pointing of the underwater vehicle's camera. They view the images on a head-mounted display. Joysticks are used to steer the mini-submarine as it lets the scientist, via telepresence, study the lake bottom where primitive life forms thrive under remarkably hostile conditions, conditions perhaps once found on Mars. By using these telepresence tools, scientists examine the physical and biological nature of the ice-covered lake, including its temperature, chemical composition, and the gas content of the water. To test the remote capabilities necessary on Mars, signals from the underwater ROV's camera were sent from the Ross Ice Shelf Base to McMurdo Station via laser beam. From there, microwaves sent the signals to Black Island, where they were uplinked 35,000 kilometers to a communication satellite. The signal was then picked up in Vallejo, California, where it was relayed to NASA's Ames Research Center in Mountain View. At Ames, a scientist used a telepresence headset to view images from the ROV's camera. As the scientist turned his head, signals were sent back to Antarctica to control the direction of the camera submerged below the ice more than 10,000 kilometers away. The use of this satellite link from Antarctica was one focus of a special episode of the ABC network series Nightline.
A harsh landscape, the most hostile climate on Earth, and a living laboratory for studying a threat to the global environment. Tonight we go to the Antarctic for the first live television transmission from the icy continent, where ABC science editor Michael Gillen is near the American base at McMurdo.
That's right, Chris. I'm able to speak to you live tonight because of an unprecedented system of laser beams, microwaves, fiber optics, and communication satellites, all put together.
The NASA studies are the first to use these telepresence tools to accomplish science in a harsh environment such as Antarctica. A satellite hookup similar to the one recently tested may be used to control ROVs on Mars from a Martian base. NASA's telepresence studies in Antarctica may open up applications in a variety of extreme environments where humans venture at their peril. By further developing and testing telepresence in places where explorers face real hazards, the synergistic link between humans and robots will be ready when human exploration of Mars begins.